You can trust your eyes, right? Well, not exactly. Your brain lies to you thousands of times a day, not because it wants to, but because it's trying to save energy. Today, we're diving into some of the most mind-bending optical illusions ever created, each revealing something fascinating about how your brain turns raw light into the reality you think you see. You'll discover illusions so powerful that they can make still images move, distort faces in front of your eyes, and even make you question which way gravity is pulling. And the craziest part, every single one of them has been studied by real neuroscientists at places like MIT, Stanford, and the University of Glasgow to better understand how our minds work. Let's start simple. Imagine staring at a spinning spiral for a few seconds. Then when you look away, the wall behind you starts to breathe. You didn't take any weird pills. That's called the motion aftereffect, and it's one of the oldest illusions known to science. When you stare at a moving pattern like swirling lines or shifting colors, certain neurons in your visual cortex become overstimulated and begin to tire. When you finally look away at something, still, the brain tries to balance things out. It interprets the lack of motion as movement in the opposite direction. It's basically your brain saying, "Wait, something's off, better fix it." Fun fact, this same principle is why after you've been staring out the window of a moving train, the ground seems to glide backward when the train stops. But the human mind doesn't just misread motion, it can also warp space itself. Next, let's step inside a room that makes giants and dwarfs appear in the same shot, even when they're actually the same height. If you've ever seen a photo where one person looks like a giant and the other like a doll, even though they're standing in the same room, congratulations, you've just met the Ames room illusion. Named after American ophthalmologist Albert Ames Jr., this room is a masterpiece of perspective trickery. At first glance, it looks perfectly rectangular, but from above, the secret's clear. The walls aren't parallel. The floor and ceiling are slanted, and the window through which you view it is placed at the exact angle that fools your depth perception. Your brain assumes the room is normal because it expects right angles and straight lines. That's how it's evolved to process architecture. So when someone walks from one corner to the other, your mind keeps the room stable, but stretches or shrinks the person to make sense of what you see. In fact, researchers at the University of Glasgow's Visual Perception Lab use illusions like this to study how the brain judges scale and distance. Your mind doesn't measure absolute size, it measures context. That's also why movie directors love this effect. Think of The Lord of the Rings. Gandalf looks massive next to the hobbits, but they're actually the same height. The filmmakers used forced perspective and angled sets inspired by the Ames room to sell the illusion. And while space can be distorted by geometry, the human face can be warped by something even stranger: your own brain's adaptation filters. Ever stared at a face for too long and watched it twist into something monstrous? That's not your imagination. That's the flashed face distortion effect, an eerie illusion that shows just how quickly your brain can turn familiarity into nightmare fuel. Here's a fun experiment you can try right now. Stare at the cross in the middle of two faces, any faces, and after a few seconds, you'll start to see them morph into something monstrous. Eyes bulge, noses distort, mouths twist. But if you look directly at either face, they look perfectly normal again. This bizarre phenomenon is known as the flashed face distortion effect, discovered by researchers at the University of Queensland in 2010 completely by accident. They were testing how people process faces in rapid succession, and what they found shocked them. Our visual system exaggerates small differences when faces are seen side by side, back to back. Essentially, your brain is trying to average out multiple faces at once, but in doing so, it overshoots, emphasizing every odd feature. It's like when a photo editor sharpens an image too much and suddenly everyone looks alien. The same principle drives other visual distortions, like when you stare at a spinning pattern and the world ripples afterward, or when stationary shapes start to pulse, twist, or breathe. These effects are reminders that your vision isn't a camera, it's a constantly updating prediction engine. Speaking of moving illusions, let's look at one that tricks even scientists: the stepping feet illusion. At first glance, two bars seem to walk across the screen like feet moving step by step. But if you remove the background stripes, the walking disappears, they just slide smoothly. The secret: contrast. The alternating black and white lines change how your brain tracks the motion of each bar, making it look like they're walking in sync. The world around you feels solid and reliable, but effects like these prove that your perception of reality is a carefully edited film with your brain as both the director and the special effects team. Our eyes detect motion not as absolute velocity, but as differences in contrast brightness and edge transitions. That's why simple animations or shadow shifts can feel alive. Your brain fills in motion where none exists. This illusion demonstrates a deeper truth perception isn't about accuracy, it's about efficiency. Your brain chooses the fastest explanation for what it sees, even if it's wrong. And if you think color is safe from deception, wait until you meet an illusion that changes hues before your very eyes, even when nothing's really changing at all. Let's do a little experiment. Focus on the center of this spinning circle, the one filled with tiny colored dots. As it starts to move, you'll notice something strange. The colors seem to freeze. They look constant, but they're not. Each dot is still changing color. Your brain just stops noticing. This is called the silencing illusion, and it's a perfect example of how motion can hijack perception. When objects move, your visual system prioritizes tracking position over detecting change. It's a survival trick hardwired into your biology. When a predator runs at you, your brain doesn't care if it's getting darker or lighter. It just wants to know where it's going. Neuroscientists at Harvard have shown that the brain has a kind of attention budget. When movement enters the picture, your attention gets reallocated and smaller details like color variations are filtered out. It's the same reason you might miss a flashing road sign while driving at high speed. Your brain is too busy calculating motion and depth to care about hue shifts. And color doesn't just vanish. Sometimes it rewires itself entirely. Take the afterimage illusion, stare at a red square, then look away at a white wall, and suddenly a greenish-blue version appears like a ghost. It happens because your photoreceptor cells adapt to overstimulation, producing the opposite color on the spectrum once the stimulus is gone. You'd think by now geometry would be something we could trust: angles, lines, logic. But our brains are far too eager to see patterns, even when those patterns can't exist. Meet the Penrose illusions, created by mathematician Lionel Penrose and his son physicist Roger Penrose. Yes, the same Roger Penrose who later won a Nobel Prize in physics. These are the impossible objects that break the rules of three-dimensional space: the Penrose triangle, the Penrose stairs, and the impossible cube. At first glance, they look perfectly real, but if you try to trace one with your finger, your brain short-circuits. Each connection makes sense locally, but not globally. It's like an Escher painting come to life. What's happening here is called top-down processing. Your brain isn't just seeing what's in front of it, it's predicting what should be there based on memory and experience. It fills in gaps, completes shapes, and builds 3D structure from 2D clues. Artists and architects have been obsessed with these illusions for decades. M.C. Escher's Ascending and Descending uses Penrose stairs to depict monks walking in an eternal loop, never climbing, never descending. Physicists studying visual perception say this kind of illusion reveals the constructive nature of vision. We don't record reality, we invent it. And this doesn't just happen in art. Filmmakers use the same trick in forced perspective, where distance and scale are warped to fool your eyes. When you see a tourist holding up the Leaning Tower of Pisa, or an actor who looks giant next to another, you're seeing geometry bend to psychology. Our minds crave coherence, so they rewrite depth and size to make the world make sense. And once you realize that, you start spotting illusions everywhere in architecture, cinema, even your own reflection. Because sometimes the illusion isn't about how things look, it's about how they move. Because even motion itself can be an elaborate lie. You're about to see something that moves, except it doesn't. Take a look at a simple pattern of circles, like the rotating snake's illusion. They appear to swirl and pulse endlessly, but every single pixel is completely still. This illusion, discovered by Japanese psychologist Akiyoshi Kitaoka, relies on contrast and tiny involuntary eye movements called microsaccades. Even when you think your eyes are still, they're actually jittering by fractions of a millimeter. Those micromotions cause small differences in brightness to flicker, and your brain interprets that as rotation. It's a reminder that seeing and perceiving are two totally different things. Another moving illusion that plays with your sense of sequence is the phi phenomenon, first studied in 1912 by psychologist Max Wertheimer. He discovered that when two lights flash on and off in rapid succession, people don't see two lights, they see one light moving. This principle gave birth to animation, from vintage film reels to modern computer graphics. A close cousin of phi is the beta movement, the illusion behind old video games and neon signs where sequential lights make it seem like a dot is moving. In reality, it's just a clever timing trick. And then there's the wagon wheel effect, where a spinning wheel under strobe light appears to stop or even move backward. That's because your brain, like a camera, samples motion in frames, not continuously. When the timing syncs up just right, it creates the illusion of impossible motion. All of these illusions teach the same truth. Motion isn't a property of the world, it's a story your brain tells in real time. Ever looked at a straight line and sworn it was slanted, or watched the floor ripple even though it's perfectly flat? Welcome to the realm of geometric deception, where your brain bends space just to keep itself comfortable. Take the Café Wall illusion. It looks like a set of sloping bricks, but every line is perfectly parallel. The trick lies in how our eyes perceive contrast. The lighter mortar lines make dark tiles appear offset. If you switch the colors to something uniform, the illusion disappears entirely. Then there's the Zöllner illusion, where diagonal crosshatching makes parallel lines look as though they're diverging. The small intersecting angles force your brain to interpret depth that isn't there, giving a 2D drawing a fake 3D tilt. And the Müller-Lyer illusion may be the most famous of them all. Two equal-length lines, one with inward-pointing arrowheads, one with outward. The one with outward tips looks longer because our brains use angles as depth cues. It's the same mechanism that helps us navigate hallways. We read lines as walls moving toward or away from us. Architects and product designers study these effects to understand how people perceive form and distance. NASA's Human Factors Division even uses Müller-Lyer patterns to test astronaut depth perception in microgravity. In space without gravity's visual cues, even basic shapes can become confusing. Another favorite is the Fraser spiral illusion, which isn't a spiral at all, but concentric circles masked by angled lines. Your brain stitches the patterns together incorrectly, creating motion and depth that don't exist. Now we reach the illusions that are less about tricking your brain and more about revealing how creative it truly is. Let's start with the Kanizsa triangle, discovered by Italian psychologist Gaetano Kanizsa in 1955. In this illusion, 3 Pac-Man-shaped figures and 3 V-shapes make you see a bright white triangle that doesn't exist. No lines, no shading, just your brain connecting imaginary dots. It's a perfect example of Gestalt perception. Your mind prefers wholes to parts, so it fills in gaps to create meaningful shapes. The result is a triangle brighter than the background, even though it's just empty space. The same thing happens in Rubens' vase, the famous faces or vase illusion. Depending on how your brain interprets figure and ground you, either see a vase in the middle or 2 people facing each other, but never both at once. This perceptual flip is your mind deciding what's the object and what's the background, a constant negotiation between focus and context. Then there's the hollow face illusion, where a concave mask of a face looks like a normal convex one. Even when you know it's hollow, your brain refuses to see it that way. Why? Because our visual system has learned that faces always pop outward. Evolution tuned us to detect expressions fast, even if it means rewriting geometry. Psychologists use this illusion to study schizophrenia and visual processing disorders, since patients who perceive the face as truly hollow show different brain activity patterns. In a way, illusions like this don't just show how our brains work, they reveal how our beliefs shape reality. And when it comes to color, that belief runs deep. Remember the viral blue and black dress? That was the checker shadow illusion in disguise. 2 squares of the same brightness appear different because of how shadows influence context. Your brain compensates for lighting automatically. MIT scientist Edward Adelson created it to prove that color constancy. Your brain's ability to perceive consistent colors can sometimes betray you. So after all these illusions, from shifting spirals to impossible cubes, one question remains: if our brains can't always be trusted, what's real? Neuroscientists believe perception isn't a mirror of the world, it's a simulation. Your brain builds a best-guess model based on limited data, a shortcut evolved for survival, not accuracy. As psychologist Donald Hoffman puts it, we didn't evolve to see reality. We evolved to see what keeps us alive. The Leaning Tower illusion shows this perfectly. 2 identical images of the Leaning Tower of Pisa appear to diverge, but they're the same photo. Our brains expect parallel lines in the distance to converge, so when they don't, we assume they're tilting. The same bias that helps us judge depth while driving or throwing a ball can also warp what we see in a flat image. And this useful deception runs deeper than you think. When you stare at a red dot long enough, your photoreceptors adapt and create a green afterimage. When you look at a shadow, your brain brightens it automatically so you can still identify objects. Even walking through a dim room depends on your brain lying to you. It's constantly guessing what's probably there. Modern AI vision systems, like those in self-driving cars or Mars rovers, imitate this predictive process, but they're not immune to the same errors. A misplaced shadow or pattern can completely confuse their senses, just like our eyes. So maybe the strangest illusion of all is perception itself. Everything we see, light, color, motion, depth, is filtered through an ancient biological interface. Reality as we experience it is just a version rendered by the brain. Yet that imperfection is what makes perception beautiful. It's how we find patterns in clouds, faces in the moon, or meaning in abstract art. Our eyes might deceive us, but curiosity lets us get closer to truth one illusion at a time.